everyone, in Algebra 3, today we're going to be going over the new material in Lesson 71, which is on graphing the ellipse. So in this lesson, you are going to see an equation, and this is the formula you want it to look like. It's going to be x squared over something plus y squared over something equals 1, and that should look like something you've seen before, which is called the double intercept form. And we want to get all of our equations into this format so that we're able to graph it. Now, the distance away from the origin is going to be easily calculated by just taking the square root of below the x squared and the square root below the y squared. And that's just going to be your distance away from the origin in either direction on each of those axes. So now we're going to look at an example, which they give us x squared over 25 plus y squared over 9. So that's already in the correct format that we want. So all I need to do is I need to go to each denominator. I have x squared over 25 plus y squared over 9 equals 1. I need to take the square root of each, which means that on the x-axis, I'm going to go 1, 2, 3, 4, 5 away from the origin. 1, 2, 3, 4, 5 away on the origin. And then on the y-axis, I'm going to go 1, 2, 3. 1, 2, 3. And that is going to be your ellipse. So an ellipse is just basically a flattened out circle. And so now what we're going to do is we're going to look at the next example, which looks like this. So if you notice, this one's not in the correct format. So what I need to do is I'm going to start by dividing both sides by 15 because I want the right side to be equal to 1. So that would be 5x squared over 15 plus 2y squared over 15 equals 15 over 15. I want to say that I messed this up. This must be a 3. So this would turn into x squared over 3 plus y squared over 5 equals 1. Now again, you have to take the square root of the denominators. That tells you how far away on the origin you're going to go. This one's going to be a little tricky because of the square root of a number that doesn't actually divide evenly. So I'm just going to draw a rough sketch. So if I do the square root of 3, I actually get 1.7. So that's about here in either direction. Then the square root of 5 is 2.2. So that would be up to about maybe there. And that's how you're going to connect your dots. So that's just kind of an estimation for that one because, again, we can't take the square root of a whole number. So now what I want you to do is I want you to actually pause this video. I want you to attempt numbers 1 through 10 on this lesson. And then I want you to play it so that you can then go over them with me. But I want you to attempt them on your own first. So pause this video now, attempt 1 through 10, and then we'll go through them together. So number 1 says the boat could sail 5 times the speed of the current in the river. Thus, the boat could go 144 miles downstream in 2 hours more than it took to go 64 miles upstream. What was the speed of the boat in still water, and how fast was the current in the river? So the boat could go 5 times the speed of the current, so 5W. The distance downstream is going to be 144. The distance upstream is 64. And it says it could go downstream in 2 hours more than it could go upstream. So time down is going to be the time up plus 2. This is my downstream equation. This is my upstream equation, down and up. So I'm going to start by plugging in 5W plus W times TD, which is going to be TU plus 2, equals 144. So when I add the W's together, I would get 6W times TU plus 2 equals 144. Before I distribute my W, I'm actually going to divide this whole equation by 6 and then distribute the W. So it would be W to U plus 2W equals 144 divided by 6, which is 24. Now for my upstream equation, I'm going to plug in my 5W minus W times TU equals 64. If I combine the W's, I get 4WTU is equal to 64, which means that WTU is going to be equal to 16. I can take that 16 and plug it into the left side, so that would be 16 plus 2W equals 24. So when I move the 16 to the other side, I get 2W is equal to 8. So therefore, the speed of the current is going to be 4. When I plug that into my B, I get my speed of my boat is going to be equal to 20. Okay, so you just needed both of those equations in order for you to solve that problem. Now moving on to number 2, so hopefully you've attempted this again. So 4 times the sum of the number of reds and blues exceeded 3 times the number of whites by 5. 5 times the sum of the number of blues and whites exceeded 8 times the number of reds by 13. If there were 5 more whites than blues, how many of each color were there? So for number 2, I have 4 times the sum of reds and blues, so R plus B exceeded 3 times the number of whites by 3. Then I have 5 times the sum of blues and whites. So 5 times the sum of blues and whites exceeded 8 times the number of reds by 13. There are 5 more whites than blues. So W equals B plus 5. So what I'm going to do here is on this top equation, I'm actually going to distribute the 4 and move the W to the other side. So that would be 4R plus 4B minus 3W equals 3. Middle equation, do the same thing, but I'm going to move the R over, so that would be negative 8R plus 5B plus 5W equals 13. So now what I'm going to do is I'm actually going to do elimination here with the R. So I'm going to eliminate the R by multiplying the top equation by 2. So I have 8R plus 8B minus 6W equals 6. Bottom equation, I have negative 8R plus 5B plus 5W equals 13. I'm adding those together, so I eliminate the R, and I get 13B minus W equals 19. And now I know this bottom equation is W is equal to B plus 5. So I have 13B minus B plus 5 equals 19. So that was substitution. Distribute the minus sign. So 13B minus B minus 5 equals 19. Move the 5 to the other side. 13B minus B would be 12B. And then 19 plus 5 is 24. So now I know that there are 2 blues. Once I know the number of blues, I can take that and plug it in here. So 2 plus 5 would be 7, so that would be 7 whites. Now I have to solve for the number of reds, and I can do that by just plugging it into either one of these equations. So let's just do the top equation. So that would be 4R plus 4 times B, which is 2, minus 3 times W, which is 7, equals 3. So that would be 4R plus 8 minus 21 equals 3. So that would be 4r minus 13 equals 3. Move the 13 to the other side. So I have 4r equals 16, which means that we have 4 reds. So that was just another problem where you have to do substitution and elimination and solve for 3 variables instead of 2. Now I'm looking at number 3. How many different ways can 5 students sit in 5 chairs in a row if Mark and Ophelia refuse to sit next to each other? All right, so number 3, whenever we have people that refuse to sit next to each other, it makes our life a little harder. So we have to identify all the places where they can sit in those 5 chairs. Oops. 5 chairs. So I'm just making different rows with 5 chairs in it. So I'm going to start identifying where Mark and Ophelia can't sit because they refuse to sit next to each other. So I'm going to start with saying that Mark and Ophelia would sit in seat 1 and 3. Then I could say 1 and 4. I'd say 1 and 5. So obviously going to be more. Then they could sit in 2 and 4. They could sit in 2 and 5. And then lastly, they could sit in 3 and 5. So I think that takes care of every spot. So if it's only Mark and Ophelia that you're choosing from, you're only choosing from 2 people. So it'd be 2 people to fill the first spot, 1 person to fill this third spot. And so I'm going to just go through and fill in my 2 and my 1 in all of these spaces. Mark or Ophelia, Mark or Ophelia, 1. Then to fill in the rest of the spaces, I have 3 more students left. So I would just go 3, 2, 1. Then 3, 2, 1, 3, 2, 1. Obviously, no repetition is permitted because you can't double a person. And we multiply across. So 3 times 2 is 6, times 2 is 12. So if each of these equals 12, 12 times 6 different options. My brain's not functioning today. So we would say that there would be 72 different ways that we could fill those seats. Okay, so anytime it says someone refuses to sit by someone, you actually have to identify all the spaces that they can sit in. You can't just do it all in one step like we're used to. Number 4 is an old problem. It says Tristan can do 12 jobs in 15 hours. When Isolde helps, they manage to do 25 jobs in 20 hours. How long does it take Isolde to do 1 job? So it's going to be the rate of Tristan, time of Tristan, plus rate of Isolde, time of Isolde equals jobs. The rate is going to be 12 over 15. And this one's different. It tells us that they're both working for 20 hours. So the time is going to be 20. And that in those 20 hours, they can finish 25 jobs. So this goes into 15. Well, 5 goes into both of those numbers. So 4, 3, and then 3 goes into 12 4 times. So really I have 16 plus 20 RI equals 25. Move the 16 to the other side. 20 RI equals 9. And divide both sides by 20. So the rate of each fold is going to be 9 over 20. So now what we're going to do is we're going to use the equation rate times time equals jobs. So her rate is going to be 9 over 20. We want to know the time it would take her to do one job. Multiply by the reciprocal, which would give you 20 over 9 hours. Now looking at number 5. So number 5 is tricky because we're going to have to figure out whatever happens to one side is going to happen to the other. So it says x varies directly as y squared. So number 5 starts with x equals y squared and inversely as z and inversely as the square root of w. So this is my starting equation, and then I have to see whatever I do to the right side, I'm going to do to the left. So what happens to x when y is multiplied by 3? Well, if I multiply y by 3, I get 3y, then squared. Z is doubled, so multiply that by 2, and w is quadrupled, so that would be 4w. Now I want to simplify that, so that would be 9y squared over 2z times 2 square root w. So that would be 9 over 4, and then y squared over z square root w. So what's different about this equation and this equation? Well, this part all stays the same, but that means I'm multiplying it by 9 over 4. If I multiply this side of the equation by 9 over 4, I also have to do that to x. So your answer is just multiply by 9 over 4. Whatever I do to one side after simplification, I have to do to the x as well. And that would be our result. Now looking at number 6, we have the sum of the length, width, and height of a rectangular box is 150 centimeters. The length is twice the sum of the width and the height, and twice the width is 1 centimeter greater than the height. What are the dimensions of the box? So for number 6, we have the sum of the length plus width plus height is equal to 150. It says twice the length. The length is twice the sum of the width and the height. So the length is 2 times the width and the height. And twice the width is 1 centimeter greater than the height. So twice the width is 1 centimeter greater than the height. So height plus 1. So I'm going to do here is I'm actually going to distribute the 2 and then set it equal to 0. So that'd be L minus 2W minus 2H equals 0. This equation I'm going to set equal to H. So that would be H is equal to 2W minus 1. So I'm going to plug that into this equation and this equation. So it would be L plus W plus 2W minus 1 equals 150. So that would be L plus 3W equals 151. Now this equation here would be L minus 2W minus 2 times 2W minus 1 equals 0. Distribute. L minus 2W minus 4W plus 2 equals 0. So L minus 6W equals negative 2. I'm going to do elimination. So I'm going to multiply this one by negative 1. So that'd be negative L plus 6W, right, equals 2. So I have 9W equals 153. So the W is going to be equal to 17. Now that I know what that is, I'm going to plug it into that equation right there. So h is equal to 2 times 17 minus 1. So that would be h is equal to 33. Now I just need to solve for L. So so it says the sum all adds up to 150. So for L, it's basically going to be 150 minus 17 minus 33, which would give me the length is equal to 100. And those are your results for number 6. Now number 7 and 8, I hope you guys attempted before doing it with me. So it says graph the ellipse. So the only thing you have to do for this one, it's already in the correct standard form, is you need to take the square root of each. So x squared, the distance is going to be the square root of 16 away from the origin. And for y squared, it's going to be the square root of 9. So that'd be 4 away and 3 away. And you just need to connect the dots. And that's your result for number 17, or number 7. Now looking at number 8, so this one is not in the correct form. So what you would have to start by doing is dividing everything everything by 36 so that you're able to put it into the standard form. So 9x squared over 36 plus 4y squared over 36 equals 1. So this would simplify to x squared over 4 plus y squared over 9 equals 1. And then all I need to do is take the square root of each of those. And that means on the x-axis, I would go 2 away from the origin. On the y-axis, I would go 3 away from the origin. And that's all you have to do. Now looking at number 9. So a doctor believes that the systolic blood pressure of her patients is approximately normally distributed with a mean of 120 and a standard deviation of 10. If she is correct, what percentage of her patients would have a systolic blood pressure greater than 135? So this is going to be it from your last lesson, and you need to be able to calculate the z-score. You also need to get out your standard normal table that looks like this. So I'm going to start by just calculating the z-score. So the z-score, remember, the equation is x minus the mean divided by the standard deviation. Our x is the 135, the value we're actually trying to focus on. The mean is 120, and the standard deviation is 10. So I have 135 minus 120, and then divide that by 10, which gives me 1.5, positive 1.5. So if I were to draw this graph, this would be the mean at 120. We're looking at about 135, which is 1.5 standard deviations away from the mean. So on my chart, this will give me the percentage that falls below. So I'm going to go down to positive 1 over to 0.5, which gives me 93.32. But that's the percentage that's going to fall below. So that means that percentage would be 93.32%. But I want to know this percentage above, which means all I need to do is subtract that percentage from 100. So it'd be 100 minus 93.32. And that gives me a result of 6.68%. So again, always on the standard normal table, it gives you the percentage that falls below. If you ever want to find the percentage greater than that, you would have to subtract it from 100. Now the last one we're going to look at is our matrix. So this one, remember, you start in the top left, multiply by bottom right, and then subtract top right times bottom left. So top left would be x plus 1 times bottom right, which would be x minus 1, minus 1 times x equals 0. So if I multiply that out, I'm going to get x squared plus x minus 1 minus x equals 0. These two x's are going to cancel, so I get x squared minus x minus 1 equals 0. Does that factor evenly? No. So what I'm going to have to do is do quadratic formula. So x is going to be equal to negative b plus or minus the square root, b squared minus 4 times a times c, all over 2 times a. So two negatives make a positive. 1 plus 4 is 5, so that would be square root of 5 over 2. And that concludes all the problems that we're going to do on this lesson, lesson 71. I hope you guys all have a great day. Bye.